Hello everybody. In today's video we are going to be talking about cable television, in particular analog cable television. And we're going to do that using two devices that I recently acquired. That's right, today's video is a 2-for-1. One of these devices is a representation of where the life of a cable television channel begins. The other device we're going to look at is a representation of where the life of a cable television channel ends and where it can be watched by the end user. This is a standard communications model TVM 550 Mark II. This is a cable television modulator. What this does is it takes in a composite video signal along with mono audio in the case of this particular model, and it modulates it onto a specific cable channel. And actually, this particular modulator is of a class called agile modulators. And what that means is they can modulate the video and audio onto a cable channel of your choosing. You can select any channel from the roster of channels that a particular modulator provides. These devices are pretty neat. They are not only neat in what, they were meant to do in their original life, but if you're a vintage television enthusiast, having one of these can actually be pretty useful as well. So these cable modulators are more or less where the life of a cable television channel begins. And here's how they work. You are a television station. Big or small, doesn't matter. But you are lucky enough for your local cable company to want to carry you on their system. And here's how that works. At the TV station, you have one of these modulators, and you set up an agreement with an engineer at the cable company, and they run a direct cable line from your TV station to a facility they have called a cable head end. A cable head end it's almost like a central office for the telephone network, but it's for the cable network. At a cable head end, all of the TV stations and satellite premium channels and everything that the cable company wants to carry on their system, that's where all of those feeds come in, and then the cable company combines those feeds and amplifies them and sends them out onto the cable network where they can be picked up by all of the subscribers' cable boxes. So you're a TV station and your channel gets to be carried on the cable network. You are going to be given one of these modulators by the cable company, and a direct cable line is going to be run between your TV station and the cable head end. And the job of this modulator is to take a composite video feed from your TV station and modulate it onto some RF channel chosen by the cable company's engineer and sent out over that dedicated line to the cable head end. From there, the cable head end demodulates that incoming RF signal back into the composite AV signal from whence it came, and remodulates it onto another channel, whatever channel that the cable company has decided that you deserve to be on. So there's actually two of these in play between the TV station and the end user. One of these to send the signal from you to the cable head end, and then another one to go from the cable head end to the end user on the actual cable channel that the end user is going to receive it on. Now, having a direct dedicated cable feed between the TV station and the cable head end is only one way that this can be accomplished. Another way that it can be accomplished is that the TV station can actually modulate its feed directly onto the cable network that the end user receives, but it does so on a channel that's not accessible by cable subscriber equipment. These are called T channels, and they're at a far lower frequency than normal cable channels. So you basically have a standard cable television hookup available to your station that you hook a modulator like this onto. It's got to be a special modulator that can modulate on these T channels. This is not one of those. But you basically have a cable subscription feed going into the station. You hook your modulator, your T channel modulator, onto this, and you inject your feed directly onto the cable network, but sort of under the wire, if you will, on one of these special channels. And the cable head end is also listening onto the main cable network, listening in onto these special channels. It picks up your feed, remodulates it onto a normal channel, and sends it out for the end subscriber. So that's a couple of ways where these were deployed between a TV station and the cable television system. Now, if you were a really tiny television station, like we are, but even tinier, when we started in 1993, we were a cable-only channel. However, we did not have a line to the cable head end from the TV station. Our studios were just that. They were only studios. And the cable company decided that because of how small and relatively insignificant we were, rather than the cable company having to set up equipment to enable us to feed our station onto the cable network, the cable company said, hey, you come here with your program tapes and do it from our head end. And that's the way we did it for the first several years of operation, I think. Once we had a taped program from our studio, when it was time for that program to go on the air, we had, back in the early days, we had one television program, that's all we had, and it broadcast twice a day. For the rest of the broadcast day, it was just the community calendar. So we had our taped program that we taped at the studio. We had it on a VHS, because that's what we used at the time. And we had to take that tape, drive to the cable head end, which was in another town, and we would use their VCR. They had a VCR, a VHS VCR set up at the head end for us. And that VCR was connected to a modulator that modulated that VCR's output onto, initially it was channel 4, later we were channel 10, like all of the Fundy cable community channels. So we had to drive when it was almost broadcast time, we had to drive our tape to the cable head end, stick it in the VCR, and when the clock hit the top of the hour, we hit play, probably flipped a switch to go from the community calendar to the VTR, and the program played. And you sat there while it played, and when the program was done, you flipped the switch again to go back to the community calendar, rewound the tape, and then you were ready for the next time it had to air. And that's how we did it. There was actually no cable facilities at the station. It was all centralized at the head end. Later, once we had, a normal broadcast day with multiple programs, and it was no longer feasible to drive to a remote location to air those programs from the tapes, the cable company set up the modulation equipment for us so that we could send a feed to the cable head end. But yeah, that's mostly how it was. If the cable company carried premium channels, it would probably receive those channels over satellite. So the cable head end would have a satellite receiver. That satellite receiver would output a composite video signal. It was fed into a modulator like this one and sent over the cable network on a particular channel. But a broadcast environment was not the only place that these cable modulators saw use. There was actually a couple of, let's say, civilian uses for these as well. And that was schools and hotels, and they were basically used in the same way. Let's say you're a school. You're a school and you have a local television station that you want to make available to the students. you can receive that local television station over the air, let's say. But of course, a school being the way it is, any big building being the way it is, there's probably some rooms where you can pick up that station over the air, and some rooms where the signal's not good enough. So what some schools did was they would have a singular rooftop antenna that could receive the local station that they wanted to receive. They would use a cable demodulator, which is basically one of these but backwards, to receive that over-the-air signal and then demodulate it onto into composite video, and then they would send that composite video into a cable modulator, and the purpose of that modulator was to distribute that signal throughout a local cable network within that building, and any TV hooked up to that cable jack in any room could pick up the channel with perfect signal quality because it was all coming from a central antenna rather than each TV having to try and pick it up with its own antenna. Hotels did the same thing. A hotel may have several modulators like this in a closet somewhere, each of them picking up a different local TV station, and they would use these modulators to put out a signal strong enough to be distributed throughout the whole building to every cable jack in every room, and every TV could pick up that channel. Because see, a normal RF modulator, you know, you've seen little boxes that you can plug in a composite video signal and modulate it onto channel 3 or 4 usually. Those output a signal strong enough to go directly to a TV, but if you try to send it over a long distance, you're going to get at best a fuzzy picture. Well, these output a much stronger signal than a standard consumer RF modulator. So they're able to send a signal over miles even, and the signal will retain perfect quality. And that brings me to the last use, and what is probably today the most common use that these modulators, which have long been retired from their original use, now serve. A long time ago, vintage television collectors discovered that if you take one of these cable modulators and instead of a cable being plugged into the output, you plug an antenna into the output, these things will actually generate a strong enough signal to broadcast whatever you put into them wirelessly. And depending on the antenna you use and how powerful the modulator is, you can get a range of dozens, if not hundreds of feet using an antenna plugged into one of these. It is very illegal, and I don't condone trying that with one of these at all. But that's what vintage television enthusiasts are using these for these days, which is very cool. The most popular ones are made by a company called Blonder Tongue. And I think these ones, made by Standard Communications, I think they kind of fly under the wire. I certainly didn't know that these existed until I got this one. But that's what people do. They take these, plug in a composite signal of their choosing, hook an antenna up, and you can use a vintage TV anywhere in your house, basically, using an antenna. This is particularly good if you have portable TVs, like Sony Watchmans, like handheld TVs. It makes it possible in an era where virtually no analog television stations exist anymore. It makes it possible to use those handheld TVs as they were originally intended. Even if it's just within your own home, it's still really darn cool. So let's take a look at this thing and see what we got. Starting off on the front panel, we have a power LED. We have an LED that warns you if the video signal is overmodulated, and we'll talk about that later. We have an FCC offset light. We'll talk about that when we get around the back. And we have a light that lights up when the RF output is active. Whenever you change channels, if you change channels, it turns off the RF output while you're changing the channel. Once you've settled on a channel, for at least a couple of seconds, it turns the RF output back on. That's a good thing to do. So you're not suddenly doing spread spectrum broadcasting across multiple channels when you're just trying to change from one channel to another. We have an LED display that tells you what channel you're outputting on. We have your channel selection knob. And we have some trimmers here. One is for video modulation. Again, we'll talk about that later. One is for the video audio ratio. That's kind of a weird, that's something that you kind of set where it should be and then never touch it again, and you have to use a waveform monitor to examine the RF signal. I don't friggin' know. I just have it set to the middle detent position and it works fine. And then RF level is the output RF power level. And you can adjust how strong the output signal is, which is nice. Now, these standard communications modulators, you had a choice of audio modules that you could choose from. The base was a mono audio module, which is what this has. There was also an MTS stereo module. That would be darn cool if this had that, but oh well. And then there was a module that gave you MTS stereo with secondary audio program. But on the audio module, we have a VU meter, or as it calls it, an audio deviation indicator. And then over here we have a trimmer labeled audio deviation. That's your volume. And then on the right hand side we have two test jacks, which are kind of nice to have. The top one is a video test. This is basically just a loop through of the composite video signal, which is nice. If you have this thing in a rack, this is obviously a rack mount unit. If you needed to check really quickly that if you were having a problem and you needed to check that the thing was getting the composite input signal correctly, you could just hook a composite video monitor up to this, or a waveform monitor for that matter, and you could see what your incoming video looks like. And that's a BNC jack. And then also on the front below that we have another RF output, but this is not the main RF output. This is a test RF output that's been attenuated by 20 dB. So it's not a super strong signal. It's actually safe to connect a standard television set or cable tuner up to this jack. And that's, again, it's basically just a loop through of the main output but attenuated, so it's a nice way to be able to test what the RF output looks like from a technical perspective, or from a visual perspective for that matter, without having to disconnect from the main output, which is very important in a broadcast environment. You need to be able to check things and run tests without interrupting your broadcast feed. So that's the front of this thing. Let me turn it around and we'll take a look at the back. So things get a bit weird on the back of this thing, but I will do my best to decipher everything. Starting at the far left is our audio input, and you can see it's not an RCA jack. Nope, not on broadcast equipment like this. It's screw terminals. So what I've done is I just cut a female RCA pigtail and screwed it onto those screw terminals. And you have a switch to go between mono audio and BTSC audio. BTSC was just some sort of other audio standard that your cable system might have required. I think it changes like the levels and the EQ and stuff like that. Next we have an F connector for injecting your own 4.5 megahertz. I think this is for the audio subcarrier, if you wanted to generate your own audio subcarrier and inject it. Or you can just put the switch to internal and let the unit use its own. And then finally, something that I do fully understand, we have our video input. Now, a weird thing about these modulators, the blonder tongue ones are like this too. The video input is an F connector, not an RCA, not a BNC. And that's so weird because F connectors are usually used for RF inputs and outputs. And I'm sure there's probably been at least some people who get a hold of one of these and try to insert an RF signal on channel 3 or 4. But no, this is the composite video input. Why it's an F connector and not a BNC, I have no idea. Anyway, all you need is an adapter. And then we have our main RF output. This is where the amplified RF signal on the channel of your choosing gets sent out. Serial number, this thing was made in 1992, and it was made in Japan. Standard Communications was a Japanese company. And then we have some more weird stuff. If you wanted to inject your own intermediate frequency signals, this is where you do it. Otherwise, just loop the in to the out, or the out to the in rather, as has been done here. And that's how this unit was used throughout its life. And now we've gotten to the FCC offset. So I don't think the situation is the same here in Canada, but in the United States, there are radio astronomers who some frequencies in cable television are really important to do their work. So in the United States, again, not sure if Canada's like this, but in the United States, depending on where you live, your local cable system, and again, we're talking about the analog days, I don't know if this still applies today, but your cable system needed all the channels to be shifted by a certain frequency so as to not interfere with these radio astronomy frequencies. So that's what this FCC offset switch is for. Here is the unit operating. I've got it hooked up to the Sony CVM 1271 composite video monitor. Despite its name, this is really just a pretty ordinary television set, but one that offers a composite video input and that has a high resolution tube. So how I've got this hooked up is I'm just playing one of my YouTube videos on a laptop, and I've got the VGA output of the laptop going into my Kramer VP502XL scan converter. This little box takes a VGA input and it converts it to either composite or S-video. And I've got the composite output going into the modulator through an RCA to F adapter. And then for audio, I've got a 3.5mm to RCA adapter. And I'm running the audio straight into the modulator. And I've got the TV set plugged into the main output of the modulator through a 20 dB attenuator. And the reason I'm doing that, instead of using the test jack that's already attenuated by 20 dB, is because I don't have an F connector terminator, and I don't know if it hurts the unit if I power it on without anything connected to the main output. So I just figured I'll attenuate the main output and plug the TV directly into it. So as you can see, the VU meter, we've got audio coming in as well. And you know, it's kind of interesting. I have found that you can really push the audio levels quite hard with this thing. Even if the meter lights up both red LEDs, there's no distortion at all, although perhaps the cable signal goes outside of its proper bounds if you have the level too loudly, but it doesn't seem to hurt anything at all. So we're modulating on channel 13. I will change the channel here. And we'll punch channel 6 in here. And there it is. Go down to channel 2. Works just fine. So next I'll show you what adjusting the video modulation knob does. So what you'll find is that if I turn it down, you can see the video gets darker. And actually it's kind of an interesting thing where the luminance signal seems to have lowered the most, but the chrominance signal hasn't lowered as much. And if your video modulation is too high, a couple of things happen. Well, first, that overmodulation LED lights up, but you can also see the video becomes too bright, and things become very white, and it loses dynamic range, and everything is just blown out. But there's something else that happens if your video is overmodulated too. I'll turn the volume up here. By the looks of it, yeah, it does. It just pops right on. So let's get this
actually
out of the way.
turn the volume down here.
More.
And I'll turn the video modulation knob up again.
I don't even know.
Hear that?
Oh, it's got a hose. Oh, it's got a hose hookup on it. I didn't know that.
You hear that buzzing. So if your video is overmodulated, you get that 60 hertz buzz. And I'm not certain on this. I haven't actually bothered to look it up. But what I'm guessing is happening is if your video is overmodulated, the video portion of the signal bleeds into the audio portion of the signal, and then you start hearing the 60 hertz refresh as part of the audio. And this is kind of cool to demonstrate because back in the days of analog television, video modulation was actually a very important thing to keep track of, going all the way back to even just in the studio when you're taping a show, or in the field if you're gathering ENG footage. It was really important to expose your shot correctly. Because if you set up your camera and your iris was too high and your image was too bright, well, if you didn't correct that in the editing stage using a video processor, if you just let that video that was too bright go to air as is, you would cause everybody's television sets to buzz when your video that was too bright came up. So yeah, really important to keep modulation levels in check. It's not as important today in the digital realm. You don't have that problem anymore. Although it's certainly always important to expose your footage correctly. But back in the analog days, that's what you'd get if you weren't careful with your camera or your editing or whatever, and you put something on the air that was too bright. And then how you're supposed to set the video modulation is you basically put it as high as you can without the overmodulation light lighting up. So something about like that. Now you may notice, picture's looking a bit fuzzy right now. I've added another inline 20 dB attenuator. So the signal's now being attenuated by 40 dB. And the RF level's turned all the way down, so it's a bit fuzzy, but I can demonstrate here if I turn the RF level up. Clears right up. So it's kind of a good way to test the characteristics of TV tuners by giving them a weak signal and seeing how well they chew on it. So you'll notice so far that I haven't gone past channel 13 on this thing, and that's because for analog cable, only channels 2 to 13 match up with 2 to 13 on the broadcast television band. Once you get past that, the frequencies are totally different from broadcast television. So you need a cable tuner, which this TV doesn't have. But I can solve that. I have a cable tuner right here, and this is the second subject of this video. This is a Jerrold Starcom-II cable box, and it was made in 1984. The purpose of this and similar cable boxes was you plugged your cable system into it, and it could tune all the cable channels that a standard television tuner can't tune, and it would remodulate whatever you tuned onto channel 3 or 4, and it had an RF output on channel 3 or 4 that you could plug into your TV. So you just tuned your TV to channel 3 or 4 and used the cable box. Now, most cable boxes that were ever made were of an electronic type. They were usually remote controlled and had a digital display, and they were all nice and fancy. This is an earlier unit and very much more primitive. It's a push button variety. And you use this legend here to flip this switch and use the buttons to choose the channel you want to go to. It only goes up to channel 37. The newer electronic cable boxes got at least a subset of the many other available channels. There's a fine tuning dial right here. Very important, at least on a unit this primitive. Later units would have auto fine tuning, of course. And this particular unit has been modified. From the factory, this top portion here was actually a wired remote control. It connected to this bottom part through a long lead, and it was a remote control, which was very nice. Someone modified this one at some point in its life. They permanently affixed the top portion to the bottom portion, cut off the cord, and rerouted it to connect them on the inside. You look at the back of this thing, your cable system input is right there. There's your television output. There's where the cord to the remote control would have been. This was apparently rebuilt by Champagne Converters and Communication Inc. Makes you wonder if they were the ones that modified it. Maybe it had a bad cord, and this was their way of fixing it. At this time, Jerrold was a division of General Instrument. By the 1990s, they would bear only the General Instrument name. General Instrument was one of the biggest makers of cable boxes, I think, at least in the early days. Model JRX2, the R meaning remote. There was also a JSX2, which was actually a standalone version that didn't have a remote capability. And 23 week probably of 1984. And yeah, this will give us access to many more channels than this TV's onboard broadcast tuner can. So let's wire this thing up and give it a test. I now have the cable tuner hooked up. Similar fashion, the RF output of the modulators going through a 20 dB attenuator into the cable tuner input on the cable box, and the TV output is going straight into the TV set. And I'm tuned into channel 6 here. 2 to 13 work just the same on this box, so in theory you could actually hook an antenna up to this box and use it as a standard TV tuner for the VHF band. I don't know why you would do that, but just from a technical standpoint you could. Although you may be able to notice that the picture has just a little bit of snow in it, despite the fact that I'm only going through a 20 dB attenuator now and not the 40 dB of attenuation. And that goes to show how much stronger of a signal a cable tuner expects than a broadcast television tuner. So I actually have to crank up the RF level pretty high, and there it's cleared up. So it just goes to show how strong of a signal these cable modulators put out compared to a standard consumer RF modulator. But we now have access to the extra channels, so I'll go to 14 here. There's 14. You got your fine tuning dial, which in most cases you can just set it once and forget it. You can go up even higher. Channel 24. There it is. Channel 36. There it is. And that's basically it. The thing works perfectly, which is kind of funny considering how much it was hacked together by someone. But yeah, it works fine, produces a good picture, seems to be a perfectly healthy device. Now, funny enough, I've gone up to 36 here. 37 does not work how you'd expect. If I output on 37 here, I don't get anything. And for a while, I thought channel 37 just didn't work on this box. But then I discovered that channel 37 on this cable tuner maps to channel 98 on the agile modulator. Very strange. So I don't know what's going on there. I do know that channel 37 was a weird channel in the broadcast world. There's actually no TV station in North America that has ever operated on channel 37. And I forget why, but it's just a special frequency for some reason. So the FCC decided never to allow a channel to operate there, and Canada followed suit. But I don't know where that stands in the cable world. But yeah, 37 on this cable box maps to 98 on the agile modulator. Now, of course, the cable box is from 1984. The modulator's from 1992. It's possible that in that time, some frequencies shifted around. I mean, this cable box was made apparently before there was even a channel higher than 37. So yeah, it's possible some stuff changed back in that time. But yeah, the thing works just fine. Now, my Sony CVM is a good representation of a television set with a very rigid tuner. It's very unforgiving and will not tune into signals that are off frequency by more than a little bit. But a lot of other TVs, in fact, I think most other TVs, are not like that. And it turns out that a lot of cable channels are actually kind of close in frequency to certain broadcast channels. For example, I have the modulator tuned to channel 70. Cable 70 just happens to be kind of close to UHF 19. So on this newer TV, which has a much better time tuning into sloppy channels that are off frequency, I can go to UHF 19 and it tunes right in perfectly fine. And this doesn't have to go for modern TVs either. A vintage TV with the old-fashioned knob dial tuner, well, I think most of them have fine tuning on the inside knob as well, and you can also tune those into these cable channels by going to the appropriate UHF frequency. For cable 70, it's 19. For cable 71, I think it's 20. Let me just check that. Yeah. And so a lot of cable channels somewhat correspond to certain UHF channels. Beginning in the 1980s, many high-end TVs began to have built-in cable tuners, negating the need to have a cable box. And by the end of the 1990s, a cable tuner was pretty much standard on any TV pretty much 9 inches or larger in size. This TV has a built-in cable tuner. You can see I'm modulating on channel 22, and it picks it up just fine. Go to another channel. Nice. And there you go, even the highest channel this modulator outputs works just fine. Very neat. Consumer VHS and Betamax VCRs have always had television tuners of some sort, but beginning in the 1980s, some high-end VCRs began to be equipped with cable-capable tuners. And this Panasonic VCR from 1988 is no different. If I just switch the tuner mode to cable and punch in channel 57, there it is.
Although oddly enough, once you get to channel 65 and above, at least I think 65 is included, yeah, once you get to channel 65 and above, all of a sudden it can't tune it in anymore. The signal is super weak. And I can crank the RF level up, and the picture clears up, but it still doesn't look quite right, so I don't know if there was some standard from channel 65 and above that's different between the VCR and the modulator, or if this VCR's cable tuner just doesn't do very well on 65 and above. But on all the lower channels, it works just fine, as you can see. And if I go back into the broadcast TV mode, can this tune in cable 70 on UHF 19? The answer is kinda yes, but again, the signal is super weak. So it's just not a forgiving tuner for anything that's slightly off frequency. The last thing I want to demonstrate today is the ability of a TV set with a infinitely variable tuner to pick up cable channels that a TV with a standard tuner that only goes from one channel to the next can't pick up. This is my Sony Watchman FD30. It's the first handheld TV I've ever owned. I've had it for 13 years, and unfortunately I won't be using this to demonstrate this because after 13 years of ownership, this thing is finally broken. Still turns on, still tunes in just fine. The volume knob of all things broke, so it's stuck at the bottom now. The little red scale moves up, but the actual potentiometer itself does not move. Or it is moving. I've been inside this thing. The potentiometer is moving, but it failed internally. So I've already got someone lined up who will pay me the cost of shipping to get this thing. So sad. I loved this thing. It's also the best transistor radio I've ever used. But such is life. So to demonstrate, I'm going to be using the Sony Watchman FD210 from 1982, the oldest handheld TV I own. Actually, right now, it's the oldest TV I own, period. But I'm modulating on channel 13 here, and I'll just plug into the external antenna jack. So if there's anything we've learned in this video, it's that every TV tuner is different. They all have different characteristics regarding what they are willing to tune in or not tune in. Now, this TV actually won't pick up the cable channels between broadcast 6 and 7, although my Casio TVs, of which I have many, and I fully intend on making videos of them in the near future, hopefully, they tune in the cable channels between 6 and 7 just fine. This thing won't, but if I modulate on cable 23, which is a channel above VHF 13, it's very hard to come in, but it does. If I go to 27, which is even farther above 13, yeah, it doesn't come in. I can try going to the bottom of 14. Nope, not that either. But cable 56 to 64 are just below 14, so let me go to 56. And it's kind of interesting. You can see the horizontal blanking interval and the vertical blanking interval. It's very weird. But I can't quite pull it in. But if I go to 64, which should be just below 14. Almost. There you go.
Into contact with the cinema. He asked the animators to make versions of well-known songs so that audiences could sing along. Grierson reasoned that this would unite people in the often makeshift cinema.
Although the audio's a bit distorted. I don't know if that's the signal or if that's just the vintage documentary I'm playing here.
And then, of course, cable 65 to 78, as mentioned before, are approximately UHF 14 to 27, respectively. So if I go to 65, I should be able to tune that in pretty easily. Yeah.
Animated songs was George Denning's Caderousse.
And if I go to 78, I should be able to go to UHF 27. And there it is. So yeah, every TV tuner is different, but you can see here, pulling in at least a few cable channels is possible. In fact, when I was in university, and I believe I showed this in a video I made at the time in my first year of university, so this was 2012, I brought my FD30 with me and I hooked it up to the cable port that was in my dorm room, and I was able to pick up, I think, just one channel. It was some sort of parliamentary channel, and I think I was able to pick that up because probably at that time in 2012, cable channel scrambling was in place, which we haven't touched on today because this modulator doesn't scramble channels, and that's just a whole other can of worms that I'm not going to get into. But it's possible that there were multiple cable channels available, but they were scrambled, but that one channel was unscrambled, and so I was able to pick that up on the Sony Watchman. Good times. Well guys, that's about all there is to show of the Standard Communications TVM 550 Mark II Agile Cable Modulator from 1992 and the Jerrold Starcom-II Cable Tuner from 1984. I'm just super happy to have this modulator. I have wanted a cable modulator for a long time. Really happy to have this one. Really happy that it's working great, and I fully intend on putting it to use. It's going to really help me with making videos on certain topics in the future. This cable box, pretty neat. I mean, it's pretty uninteresting. It works just fine and does a very simple job. I'll keep it around just because it could be useful for using in conjunction with this. So yeah, this is pretty cool, and I look forward to making use of these. So that's it. Thank you so much for watching. I hope you enjoyed the video. Hope you enjoyed learning everything you didn't need to know about analog cable television. But that's all for now, and I'll see you in the next video.